Hi. So this video is to introduce you to the quality of life data set. This is a data set we're going to be working with throughout the semester. It's one of the data sets. And to walk you through the this week's homework assignment. Alright, so what I have up here is a link to the Quality of Life Explorer. And I'll post this on our My Courses page and also on the community site. This is a really great tool that allows us to see a map of Mecklenburg County with a whole lot of possible variables. These variables come from different sources, so you've got different years and different data available for different categories. But you see we've got information on some of the demographics of the neighborhood, and if we click on something like age of residence, it shows us what the neighborhoods are like. And sometimes this can be very, very informative. Over here for each variable they give us a cumulative distribution. And so what this tells us is, the lowest, I guess it's the lowest quintile, so the lowest 20% of data of the median neighborhood ages are to about 29. So it looks like the lowest 20% of neighborhoods have a median age of about 29. The next lowest 20%, so the lowest 40%, have median ages up to about 32. The 60th percentile is at about age 34, 35 or so. And then the 80th percentile, so the lowest 80% of neighborhoods have a median age of just under 50. Okay, so that's what that tells us. This is the cumulative distribution over here. For each neighborhood, you can kind of scroll around and see what the values are. You can click on an individual neighborhood and see what its value is. So in 2016, for this neighborhood here, the median age of the residents was 53. So there's tons of information in here that you can play around with. So what I've done for our data set is I've gone through this download process. And I've put this data into an SPSS file for you. So if you look down here at the data set, you'll see data view and variable view. And I believe I talked about some of this in the video, but in the first one of the earlier videos, but we'll go through some of this again. So data view shows you what the variables are across the top and the values of the variables here. So this NPA is the neighborhood code. So this is a neighborhood they call neighborhood 2. So if you actually want to see neighborhood 2, you can go back to the Explorer and look up neighborhood 2. We've got up through neighborhood 475. Some of the neighborhoods are not listed, so we only have actually 462 neighborhoods, even though the neighborhood codes go up through 475. Some of the other key variables, there's community, which tells whether it's Charlotte, Pineville, Matthews, etc. Whether it's in the city limits or not. So all of them that are Charlotte say Charlotte, and all of the ones that are in Mint Hill, Pineville, Matthews, they say that they're in the surrounding area. By the way, if when you look at your SPSS file you see numbers here in these two columns, you can go to View and click on Value Labels. All right, so View Value Labels if you're seeing numbers instead of these labels. All right, so there's lots of variables here. You're not going to have the full data set because it has about 450 variables. And if you're using the student version, I have to give you a shorter data set because I can only give you data sets that have 50 variables. Otherwise, it'll choke. So the data set that you're going to have to work with are always going to be shorter than this. All right, so let's make this a little wider so we can see it. So this is under variable view. Under variable view, we've got all of the variable names, and we can see actually how many variables there are. And we have 453 variables currently. A couple other things on here that are useful to you. Some of the variables have labels. Most of the variables, the names are pretty descriptive. But for some of them, they have labels like the household income 2016, clarifying that gives you the average household income in the neighborhood. So that is the mean household income. The other thing that's useful here is for any of them that are coded, if you click here under values, you'll see what the codes represent. All right, so that's a quick tour of SPSS. And what you're doing on your homework this week is you're doing some graphs and some tables. All right, so let's first analyze a qualitative variable. So I'm asking you for, on question number 1, to do a frequency table and a bar chart. So if you go to Analyze, Descriptive Statistics, Frequencies, this will give you a frequency table and a bar chart. So Analyze, Descriptive Statistics, Frequencies. Let's suppose we want to analyze, I'm going to pick one at the bottom. So, by the way, these examples that I'm giving you are not the exact ones from your homework. These are similar, just to show you what we're talking about, but they're not exactly the same ones. But I would invite you to follow along to make sure you understand what's going on. So one variable that I actually created was population density change from 2010 to 2017. So let's do a frequency table and a bar chart on that. So I'm just going to take that variable, move it over, and I'm going to click under charts so I can see the bar chart. We click continue and then click OK. We see the first thing it tells us is that there are 462 neighborhoods in our data set, and that none of the observations are missing. So what this tells us looking here is that 56.7% of all of the Charlotte neighborhoods had a population density that decreased or stayed the same between 2010 and 2017. We had 36.4% of the neighborhoods that had a mild population density increase, so they increased up to 2%, and 6.9% of the neighborhoods in Charlotte had population density increases of more than 2%, so they had large increases. So it looks like, so if I were to interpret that, I would say, what I just said, the 56.7% had, of the neighborhoods had population densities that decreased or stayed the same, etc. So it looks like a little more than half of the Charlotte neighborhoods decreased or stayed the same, and the rest had population density increases. Okay, so that's the frequency table and bar chart. All right, so another thing I'm asking you to do is a histogram. So let's do a histogram for, no, we'll figure it out. So let's go to Analyze, Descriptive Statistics, Explore. And let's pick a variable like, we were just looking at population density, so let's pick population density. So we'll move it over to Dependent List. Okay, and we're just going to leave that as is. We're not going to put anything in either one of these boxes. Now under Plots, we're going to turn off the stem and leaf, and we're going to turn on the histogram. Alright, so we turned off the stem and leaf, we turned on the histogram, and then we click OK. And here, you can do the statistics also if you want to, but let's just turn off the statistics and look only at the plots. So if we click OK, this tells us that in 2016, the population density in most of the neighborhoods was between 0 and 10. We'd have to look at what those units are. It's probably people per square or something or other. We could look that up. So most of the neighborhoods were between 0 and 10. The peak was at about 5. There were a few neighborhoods to the right of that. A few neighborhoods had higher population densities than that. And the highest one was way up here at about 35. This is clearly, to me, skewed to the right. So interpret that as, tell what it tells about the data, but also give it a shape. Okay, so that one is skewed to the right. And by the way, there's a data set, or not a data set, but there's an Excel file that I will post for you that gives metadata where you can actually look up how they're measuring something like population density. So under metadata, if you look up population density 2016, it says it's the number of people per acre. All right, so most of the neighborhoods in Charlotte had, what's it? Somewhere in the 0 to 10 people per acre. Whereas one of them was very highly dense. It had about 32 or so people per acre. All right, so that's the histogram. The next thing I want you to do is a cross-tabulation. So for a cross-tabulation, let's go to Analyze, Descriptive Statistics, Crosstabs. And let's pick something like city limits. So whether the neighborhood is within Charlotte or in one of the other communities, versus population density change. And then I do want you to do either the row percentages or the column percentages, and you can pick which one. Just be very careful how you interpret it. So here I'm going to pick row percentages. So click Continue, and then click OK. And so what we see here is that of all of the neighborhoods in the Charlotte area, 53.5% of them had a population density that decreased or stayed the same between 2010 and 2017. If we compare that to the surrounding area, of all of the neighborhoods in the surrounding area, we had 70.9% had a population density that decreased or stayed the same. Okay, if we had done the column percentages, it would have been of all of the, if we're looking at this column, of all of the neighborhoods where population density decreased or stayed the same, what percentage of them were in Charlotte versus what percentage of those were in the surrounding area. All right, so that's the cross tabulation. Another thing I want you to be able to do is a clustered bar chart. So let's go to Analyze Descriptive Statistics, Explore again, and let's look now at population density by community. So if we take our community variable, move it over to factor list. Now it's going to look wonky if you do it backwards, so make sure you put your community variable or your city limits variable, whatever your categorical variable is, should be in factor list. All right, and then population density or whatever your quantitative variable is in dependent list. So we'll click OK, and this time what we want to look at, we don't really want to look at these all these different histograms. What's interesting to see is the population density by community. It looks like our very highest population density area was in Charlotte. Most of the rest of these look pretty close to about the same. I would say roughly the same. You do have an outlier in Mint Hill, and you do have several outliers in Charlotte, and then 1, 2, 3 extreme outliers. And remember, these numbers here tell you what row you're looking at. So this one is row 84 in our data set. So if we want to look at row 84 in our data set, we can see, we have to go back to data view. Look at row 84, and that tells us what this, that's what this neighborhood is. So we could look and see that's NPA 86, and we could actually go back and see where that is on the Quality of Life Explorer on that website. All right, so one more, and that's a scatter plot. So let's look at a scatter plot. So let's go to Graphs, Legacy Dialogues, and then Scatter Dot. So we'll pick Simple Scatter, and let's look at a scatter plot of population density, say population density 2017, and let's look at how that relates to voting participation. All right, so voter participation in 2016. It's not a huge deal that those are not the same year. Those probably aren't going to change that much from year to year. So we want to see how population density relates to voter participation. So we'll click OK. And it looks like there's a little bit of a relationship. It's not a very strong one, but it does look like there's a negative slope there where the higher population density areas have lower voter participation rates. Sometimes the scatter plot does not show a relationship at all, and that's okay. If it doesn't show a relationship, you can say that. Or if it shows, in this case, kind of a weak relationship, that's all right too. But I think we can see that there is a relationship here. All right, so that's it for this video. This should help you a lot on your homework. But I will be around, so if you have any questions, let me know.